Hello everyone, welcome to this new video. In this today's video, we'll be solving the problem sum of upper and lower triangles. It's an easy level question, and the company tags are not mentioned, but the topic tags are matrix and data structures. Okay, so let us go through the question. Given a square matrix of size n by n, print the sum of upper and lower triangular elements. Upper triangle consists of elements on the diagonal and above it. Lower triangle consists of elements on the diagonal and below it. All right, so this statement must be given some excessive attention. So you people might be thinking diagonal is only counted once, but that's not the case. Upper triangle consists of elements on the diagonal as well as above it. Similar is the case with lower triangle, so consists of elements on the diagonal and below it. So what can we infer from this? That diagonal elements are being considered in both the upper triangle and the lower triangle. All right, so this is the example one given. That let us see that on the notepad. So your task is to read the input. This is pretty straightforward. Like the expected time complexity is O of n by n. So that's expected because we cannot find all the values without traversing the whole matrix, right? So it's basic sense that we actually need to traverse the whole matrix to find the values that are there. So it's of course O of n by n, but the thing is it is auxiliary spaces O of 1. That's it. So for that reason you need to use some basic common sense, nothing else apart from that. So once you use that, you'll actually able to identify what are you actually trying to do, and you can give the required output. All right, so n goes up to 10 power 3 and matrix of I comma I of j, matrix of I of j goes up to 10 power 6. All right, so these are some of the things that need to be noted, and you can see the code on the right side. It's pretty simple. You could have understood what are we trying to do by this thing itself, but let us dig deep on this. So this is the example that's been given. N equal to 3, matrix is 6 5 4. Let me write that: 6 5 4 1 2 5 7 9 7. All right, so if you could carefully see what are the upper triangular elements. Upper triangular elements are 6 5 4 1 2 5 and 7, right? So this constitutes of, okay, this one doesn't constitute, so this constitutes of upper. And what is lower? Lower is the same thing. Let us first write the diagonal so that you can avoid the confusion. 6 2 7, and write all the elements that are like beneath this, below to this: 1 7 9. Great. So these are the lower and these are the upper. So what are the elements sum? 6 plus 5 11 plus 4 15 plus 2 17 plus 5 22 plus 7 29. So the sum here is 29, and here 6 plus 1 7 plus 2 9 plus 7 16 plus 9 25 plus 7 32. So here the sum is 32. So that is the reason we written the output 29 comma 32. All right, so first we have the first value as the upper sum and second value as the lower sum. That's it. So pretty clear, pretty understandable that what we are actually expected to do. Just a small thing to be observed here. All right, just a small thing to be observed. So upper triangle, that means we are only working on these things. Okay, let me erase this stuff, blue part. All right, this is 4 and this is 7. All right, and let me erase this as well. Okay, yeah, fine, done. So when we say that working on the upper part, all right, when we say that working on the upper part, just focusing on the diagonal elements. Okay, get me all the diagonal elements, and then above the diagonal elements and right to the diagonal elements. What are above the diagonal elements? These are some of the above diagonal elements. Right side of the diagonal elements, these are the right side of the diagonal elements. So what do we observe? So if I say this is the boundary, okay, this is the boundary. So what is this boundary? It is a diagonal. It is a diagonal. So what do you mean by when I say a diagonal? Diagonal is such a path where your I is actually equal to j, right? So diagonal is such a path where your I is actually equal to j, where your row number is actually equal to column number. And when I say above to it, all right, when I say above to it and when I say right side to it, what can you infer from that? What can you infer from that? That means that when I say above in the sense I is going to be decreased, isn't it? So for example, if I'm taking the reference as this particular element, all right, if I'm taking the reference as this particular element, and if I say above to this in the sense I minus 1, isn't it? I minus 1, and right side to in the sense j plus 1. So when I say right side, your column is increasing. When I say above, your row is decreasing. All right, so in total either your row decreases or your column increases. Great, either your row decreases or your column increases when I say above or right, isn't it? When I say above, your row decreases. When I say right, your column increases. So in total the conditions would be row less than or equal to column. All right, when there is a case of your row, that is I, so this is I is less than or equal to j, all those elements will be categorized as the upper triangle elements. Okay, upper triangle elements, and this is the boundary. All right, this diagonal is the boundary. That is the main case. That is very evident, right? That is the boundary, and upper to it or right side of it is what we are considering as upper, and lower to it or left towards it is what we are considering as a lower, right? That's very evident. That's crystal clear. So this is the boundary. All right, boundary is the diagonal, and diagonal is the path where your row is actually equal to column. And to the right or to the above, we say that like we can see, to the above means your row is decreasing, to the right means your column is increasing. So in total your row should be less than or equal to column, and if it's the case your row is less than or equal to column, that means I less than or equal to j, then you can consider it as an upper element. Now what about lower element? So when I say about lower element, these are the elements that I'm actually considered. So when I say lower element, I say like let us take the reference of this itself. Okay, if I say below to this, that means I plus 1, and if I say left to it, that means column is decreasing, j minus 1. So what can I infer from this? In total I should be greater than or equal to j, or row should be greater than or equal to column. All right, if in case your particular elements row is greater than or equal to column, that means we can categorize it as a lower triangular element. All right, so in that case we'll add that to the lower triangular element. If in case it's I, that is row, is less than or equal to the column, we add it to the upper triangular element. All right, so pretty simple, pretty straightforward, very evident from this. So just a small logic, like if I is less than or equal to j, go that means it is a upper triangular element. If I is greater than or equal to j, that means it's a lower triangular element. That's it. So very simple. So that is the reason we if you can just go through the code. So first we have taken two variables, upper sum, lower sum. So if I less than or equal to j, that means it belongs to the upper sum part. If I greater than or equal to j, that means it belongs to the lower sum part, and finally we return it. That's it. Very simple code. So I hope you understood this explanation. Just a small logic, either I less than or equal to j or I greater than or equal to j. Very evident. All right, so if there are any doubts, please comment in the comment section. For your reference, codes in Java, Python, C++ are attested in the description. You can just go through them. So thank you for watching. Stay tuned.